Now that we've had a basics for probability, we're going to be talking about multiplying probabilities. And there are two different occasions here where we can have an independent versus a dependent event. So we're going to start with our independent. If I have an independent, I'm going to take the probability. So we want the probability of A and B. That equals the probability of A times the probability of B. So what does this all mean? This means that independent, we know, does not affect our second choice. So for instance, let's say that I had 3 green marbles, 4 blue, and 6 red. In order for this to be independent, you have to replace the marbles, because if I pull a marble out, it's going to affect my second choice. So I have to replace it. After replacing the marble, what's the probability of drawing a green one and a blue one? Okay, so when we're looking at this, I need to find the probability of the green one and then the probability of the blue one based on my independent formula. Okay, so the probability of the green one, well, I have 13 total. The probability of getting a green one is 3 out of 13. The probability of selecting a blue one is 4 out of 13. So the total probability then is 3 over 13 times 4 over 13. So that gives me a total of 12 over 169. And that's my probability. And this is because it's an independent event. I'm replacing the marbles so that option is still available to me. Okay, so what about I have a spinner. And those are my different options on my spinner. And I want to know the probability of spinning a blue and then a green. Looking at this, I need to find the probability of the blue and then the green. I know that this is independent because when I spin a blue, that doesn't take that little chunk out of my spinner. My spinner is still able to land on that same blue. So the probability then of spinning a blue, I've got 8 options and I can spin a blue 3 times. The option then for a green is just 1 over 8. So my total probability is then going to be 3 over 64. Now let's talk about a dependent event. So dependent, we know, is going to affect the second choice. So if I pull a marble out of a bag and I do not replace it, so my probability is still going to be A and B. It's the probability of A, and then it's the probability of B following A. So that might not make a lot of sense right now, but this next example will kind of clear that up. It'll hopefully clear the mud. So for instance, I'm going back to my marbles. I have 3 red, 4 blue, and 6 green marbles. After selecting, the marble is not replaced. And I want to find the probability of a blue and then a green. So this is where it gets a little bit different. I'm selecting the blue marble first. Okay, so my odds then of my blue marble being selected, I have 4 out of 13. But now this changes a little bit for the green marble. For the green marble, I'm only out of 12 now because I've already taken a marble out and I'm not replacing it. Now, the green, I know I have 6 green marbles, so 6 out of 12. So then for the total here, I'm going to multiply those. So I have 24 over 156, which I believe reduces, because they're both even, which reduces down then to 2 out of 13. Okay, so with this example, I'm not replacing, so I'm taking one away in the bottom here in my denominator. So this one this was starting total. And then this one here is ST minus 1. The thing to note, let's say I wanted 2 blue marbles. If I wanted 2 of the same color, this top number would also change. It would also go down by 1. So if I was selecting 2 blue marbles, the top number would change as well. So let's say that I have 3 quarters, 4 dimes, and 5 nickels. I want the probability of selecting a quarter, then a dime, and then a nickel without replacement. All right. I need to find the probability of selecting a quarter. So total, I have 12 coins to choose from. Selecting a quarter is going to give me 3 out of 12. Selecting the dime is going to give me 4 out of 11. And selecting the nickel is then going to give me 5 out of 10. So now I need to multiply all of those numbers together. So on top here, I've got 3 times 4 times 5, which gives me 60. On the bottom, I've got 12 times 11 times 10, which is 13, 20. I'm going to go ahead and reduce that fraction, and I get 1 over 22. those are multiplying probabilities. The key is to remember whether or not you have an independent or a dependent event.